Okay, let's get into it. Welcome back to the deep dive. If you thought the biggest story in AI was just about another model update, the news from December 23rd, 2025 really forces you to think again. Today feels like the day AI officially stopped being just a tool you use and became this autonomous embedded utility that's starting to run, well, everything.
It really is a critical moment of convergence. You can see the stakes immediately, both in the markets and in governance. On one side, you have this massive integration service now with a historic $7.75 billion cash acquisition. And on the other, stark warnings that the safety practices at the world's biggest labs are, frankly, failing to meet global standards.
That sets our mission for today perfectly, then. We need to get past the headlines and find the specific, measurable breakthroughs that are fueling this shift from tool to utility.
Exactly. Our sources today are everything from deep academic papers on Sparv to huge corporate announcements and policy decisions.
And the central theme seems to be this collision, right? How can the tech accelerate so fast? Getting smarter, gaining autonomy, while the governance needed to control it is so far behind.
To even begin to understand that, you have to start with the research. How are engineers actually making these systems smarter, faster, and more reliable in the first place?
Kicking off with those academic breakthroughs, then, it feels like the biggest challenge for any truly autonomous agent is managing memory and context over time. And we're seeing a fascinating solution in a paper called Memory T1, Reinforcement Learning for Temporal Dialogue Reasoning. This is coming out of ARCSA.
Right, the long context problem. It's debilitating for any agent that needs to work over multiple sessions. The model just forgets what happened, 200,000 tokens ago.
So what's the innovation here?
Well, what's so interesting is that they didn't just add more memory. They taught the AI to be its own executive assistant. They're using an RL-based memory selection policy, which means the AI learns what dialogue history is relevant and what it can just throw away.
So instead of making the model carry around every single interaction, it dynamically prunes the information. It keeps a sort of Cliff's Notes version of the conversation that it knows it'll need later.
Exactly. And the performance lift proves this is a much better approach than just brute forcing a bigger context window. This technique boosted a 7 billion parameter LLM score to a new open-source state-of-the-art of 67.0% on the time dialogue benchmark. Learned time-aware memory. That's what enables a long-running, useful agent.
Okay, so if we're building these smarter, long-running agents, we absolutely have to talk about security. Which brings us to AprilGuard, an 8 billion parameter unified moderation model published on ArcSave by researchers at ServiceNow.
And this hits directly on the risk we mentioned at the very top. Traditional safety models are like a guard at the front door. They'll stop basic toxic prompts. But agentic systems, which can use tools and make function calls, they open the door to multi-step jailbreaks. You're tricking the AI mid-workflow.
So the attack isn't in the initial prompt, it's in the operational flow later on. What makes AprilGuard different? And, why does a safeguard model need to be 8 billion parameters?
It unifies detection. It looks for both traditional risks and these sophisticated adversarial attacks under a single learning framework. It's big because it has to be smart enough to understand malicious intent across these really complex function sequences. It's filling a huge security gap, and it achieved an F1 score of 0.95 on those attacks.
So it's basically the technical foundation needed to make an autonomous utility trustworthy.
Exactly.
We've just talked about how to safely control an agent. Now let's look at making them more efficient. We're turning to Cornell University and their work on ABB, LLM agents with natural language belief bottlenecks.
This is a breakthrough in scaling. ABL introduces a framework where the agent keeps what they call a natural language belief state. It's basically a dynamically updated summary of all the task-relevant information. It uses that summary to decide its next action, instead of rereading the whole chat history.
Wait a second. If the model is only reading a short summary, a belief state, doesn't it lose critical details? That seems like a pretty big compromise just for speed.
That's the core tension they solved. They used reinforcement learning to fine-tune ABL, not just to maintain a summary, but to maintain a useful one. The result is a framework that actually outperforms standard full-context models on long tasks while, and this is the key part, keeping the memory usage constant. Efficiency here isn't a compromise, it's a capability multiplier.
Speaking of high-stakes utility, the last research piece takes us right into critical medical infrastructure. SAGE, an LLM agent for automated radiosurgery planning.
Moving AI into radiosurgery, yeah, that's about as high stakes as it gets. This agent was developed to automate treatment planning, and it was tested retrospectively on 41 brain metastasis cases. The key safety mechanism here is its explicit chain-of-thought reasoning,
Meaning it has to document why it made each decision.
right, which ensures transparency.
And what was the measurable benefit? Did it just match what a human can do?
It matched human planners on the key dosimetric endpoints, so the radiation dose to the tumor. But it also significantly reduced the cochlear dose, which is critical for preventing hearing loss. That reduction was statistically significant, with a p-value of 0.022. So the AI didn't just meet the human average, it actually offered a safety improvement.
Okay, that sets the stage perfectly for what's next. We've seen the foundational research. Now let's look at where global product competition is deploying all this intelligence.
And that competition is really heating up, especially in programming and code generation. We have major news from China. GLM 4.7 by Zhipu AI surpasses GPT-5 in programming tasks.
Zhipu AI, which most people know internationally as ZAI, they are pushing really hard here. This isn't just a general model improvement, is it? It's a very focused push on coding.
It is, and the specific metric to watch is the SWE-Bench coding benchmark. It tests a model's ability to solve real-world software problems. GLM 4.7 broke the 70% score mark on SWE-Bench.
And why is that 70% mark so important?
Because that specific milestone was previously only achieved by Anthropic's Claude Opus. This is not a marginal gain. This is China achieving parity with the absolute best Western models in a key economic domain.
And that race for real-time utility is also transforming media. A pretty fun but impactful launch from a U.S. startup. Lemon Slice 2. Real-time AI avatars from a single photo.
This is all about democratizing interactive media by solving the training data problem. This new model, Lemon Slice 2, is being called the first real-time AI avatar model that can generate a conversational video avatar from just one photo. It's zero shot.
Hold on, one photo. You don't need a few minutes of video or a bunch of different poses?
No training data. It instantly gives you a fully animated, talk-capable avatar from one photo. This completely changes the game for creating interactive media, for everything from e-commerce assistants to personalized virtual tutors.
And speaking of making this frontier intelligence available everywhere, that's clearly Google's strategy. They've confirmed the Gemini 3 Flash global rollout in Google Search.
This is the embodiment of what we're calling the Flash paradigm. The whole idea is that top-tier intelligence has to come with minimal latency. It has to be fast.
And we know this model is highly capable, but the key here is the delivery speed. What are they actually promising?
They're delivering agentic search queries, so complex multi-step questions, and real-time processing of video and images. All of it characterized by sub-second latency. It makes the highest-end AI models fast, cheap, and immediately useful in billions of searches every day. That's the shift from a tool to a true utility.
But to deliver that kind of speed, you need the right hardware. And maybe more importantly, you need AI to optimize that hardware. It's like the AI revolution is starting to eat its own tail.
Precisely. The physical layer of AI is now being optimized by AI itself. A perfect example is AMD, which just released new self-optimizing tools. The headline is, AMD releases Geek Triton V2 AI agents for GPU kernel optimization.
Okay, let's just clarify for our listener. When we say Triton kernels, we're talking about the very low-level instructions that tell a GPU how to run an AI model as fast as humanly possible, right?
That's exactly right. And traditionally, optimizing those required this incredibly deep expertise. Only a handful of people in the world could really squeeze out that last bit of performance. What AMD did was release two AI agents, Geek Optim Agent TV2 and Geek Open Evolve, that automate the entire process for their Instinct GPUs.
So the AI is automating a job that used to take months of human effort. What was the game?
A huge one. Geek Optim Agent TV2 achieved average speedups of 3.32x over the reference kernels. That massive recursive efficiency gain is what makes the sub-second latency of models like Gemini Flash even possible.
Speaking of infrastructure, there's another colossal story that really highlights the geopolitical scale of this race. ByteDance plans $23 billion AI infrastructure investment for 2026.
$23 billion. It's an eye-watering figure, and it's dedicated almost entirely to AI infrastructure. This signals a massive, aggressive push by China to close the AI compute gap with Western tech giants. This is all about guaranteeing access to compute.
And that plan includes buying specific high-end hardware.
Yes. The plan specifically includes trialing the purchase of 20,000 NVIDIA H200 chips. It just underscores that access to high-end processors remains the single biggest bottleneck in this whole race.
And now we come back to that core conflict of the day. Capability versus control. Because with all this new infrastructure and all these new agents, the data suggests safety is critically behind. We have the Future of Life Institute warning AI safety practices fall short of global standards.
This report is sobering, and it connects directly back to the agentic models we've been discussing. An independent panel found that the major AI developers, we're talking Anthropic, OpenAI, xAI, Meta, are far short of emerging global standards.
What specifically is the warning about? Is this about basic toxicity or is it something deeper?
It's the deeper threat. It's the lack of robust strategies for controlling superintelligence. The report warns that companies are just racing toward more and more capability without the basic safety architectures in place. As Max Tegmark noted, U.S. AI companies remain less regulated than restaurants. The governance is simply not keeping pace.
And that gap seems to be what's driving regional governments to act so aggressively. In the U.S., the New York governor enacts 4 AI laws, including a Frontier AI Act.
New York is joining California here and setting some powerful state benchmarks. Governor Hochul signed the RAISE Act, which is the Responsible AI Safety and Education Act. And crucially, it regulates frontier AI models, the ones big enough to pose a systemic risk, and it requires disclosure of synthetic media in ads.
So they're aiming for a unified state standard for tech regulation, putting direct pressure on any AI developers operating in New York.
Right. And we saw a massive commitment from Asia, too. Japan adopts its first national basic plan on AI development.
This establishes Japan's official national AI strategy. What's the focus of their plan?
It's a dual focus. It commits to create reliable AI while balancing innovation and risk. It's designed to help them close the gap with the U.S. and China. And it comes with a planned investment that could involve $3 trillion in AI infrastructure. It shows that safety and governance aren't an afterthought anymore. They're foundational to national AI strategy.
This acceleration isn't just technical and political, it's profoundly economic. The biggest story today, in just pure dollar terms, has to be the M&A action. ServiceNow executes a $7.75 billion acquisition of Armis.
This is a huge strategic move. It is ServiceNow's largest acquisition ever. $7.75 billion in cash. And it's aimed squarely at integrating AI-native cybersecurity directly into enterprise workflows.
It's worth pausing on that valuation. When a platform pays that much in cash, it's not for a small feature. It's a foundational, structural imperative.
Absolutely. The price reflects the immense demand for solutions that can manage the vulnerabilities that all these new autonomous agents create.
And the economic implications are now so vast, they're reaching the highest levels of global monetary policy. We saw news that the Federal Reserve is factoring AI productivity gains into economic policy.
This is a massive signal. AI has officially become a variable in macroeconomic policy.
So how are Fed committee members actually incorporating this into their forecasts?
They are now explicitly including anticipated labor productivity increases from AI in their long-term outlooks. This comes after a big NBER study that modeled scenarios where unbounded AI, highly capable autonomous AI, could increase labor productivity by 3 to 4x. AI is no longer just a tech trend, it's officially shaping long-term monetary policy.
And finally, we're seeing this full-scale enterprise integration happening globally, specifically with India's enterprise sector shifting to production GenAI workloads.
This really documents the shift from just experimental pilots to full-scale monetization in the Indian IT sector. An EYCI report showed that 47% of Indian enterprises are now running multiple generative AI use cases in production. It confirms that AI integration is now core business logic, not just some side project.
That was a tremendous sweep of December 23rd. Before we leave you, let's look at a couple of tools and code you can explore based on today's research.
Sure, if you're working in long context dialogue, the open source code for that RL-based memory model, MemoryT1, is now available.
And second, if you're interested in hyper-efficient weather forecasting, another utility where speed is everything, early access for the advanced model WeatherNext 2 is now open on Google Cloud Vertex AI.
Okay, now for the two numbers of the day, which I think really encapsulate this moment. First, we have $7.75 billion. That's the valuation of ServiceNow's acquisition of Armis, signaling the huge premium being placed on AI control and security.
And number 2, 70%. That's the milestone score achieved by China's Zhipu AI on the SWE-Bench coding benchmark, confirming that the race for technical parity is accelerating fiercely around the globe.
You know, the day confirms that AI now possesses capabilities far beyond what is currently safely deployed. It's what we call the capability overhang. And if that high-level intelligence is becoming fast, cheap, and ubiquitous, that flash paradigm, then the safety deficit identified by the Future of Life Institute becomes the central risk for the new year.
So when universal utility meets insufficient governance, does that failure of basic safety practices by frontier labs now represent the single greatest risk to economic stability in 2026? What happens when you put these highly autonomous agents into critical infrastructure without unified moderation systems like AprilGuard? It's something for you to think about as this autonomous utility era accelerates.